And under decimals today we talk about comparing them and ordering them. Like if you're at a restaurant, could I have a decimal, please? Here is something to keep in mind, ladies and gentlemen. Even though the decimal is a very small, tiny little dot there, it means a world of difference when it comes to what a number means. For example, if I have this, and I am comparing it to this, okay? Those are identical digits there. They're all 1s, 2s, and 3s, but where the decimal goes makes an incredibly big difference there. So if you are comparing decimals, you probably know this, but the first thing you need to do is look at the whole number part. Look at the whole number. In other words, look at what's left of the decimal. Okay, and if you look at left of the decimal, here's a 12, and left of the decimal there is a 1. You can stop right there because 12 is always going to be bigger than 1. You know, I could add as many digits after this as I wanted. 4, 8, 7, 3, 2, whatever. No matter what I do to that decimal number, it will never, ever, ever come close to being close to that 12. Okay? It's never, ever even going to come close to being 2. Because as you farther you get away from the decimal, the less something is worth. Okay? You alright, Jacob? If those things end up being the same, okay, then what you need to do is you need to compare the decimal. Compare the decimal digit for digit. And by that, I mean this. Let's say you've got 8.3, and you're comparing that to 8.29864. You look at the whole numbers and they're the same. 8s are all both the same there. Then what you do is you look and see, okay, the first place after the decimal there's a 3. The first place after the decimal there's a 2. And you can stop right there because 3 is always bigger than 2. Okay? It doesn't matter how many digits they have. You know, if you look at money, I mean, I can always put a 0 here. This is like having $8.30, 3 dimes. This is $8, 2 dimes, and 9 pennies. Okay, this is always going to be bigger. You go whatever digits in the 10th place, and if they were the same, then you keep going until you find a difference there. What about something like this? 3.8 and 3.80000. Comparing those, what do you think? Which one is bigger? Zach?
3.8. Well, wait, no, 3.8000000.
I'll give you the same look for that one. Wait.
They're equal.
They are exactly the same. Okay, you are always allowed to, you can add as many zeros after a decimal that you want, and you're not going to change the number. Okay, if the 3 is the same, the 8's the same, this ends with zeros, you can put as many zeros after that as you want, it doesn't change the number. If those numbers have the same digits and the same decimal place values, then they will be the same. So don't get confused on that. Don't let the book try to trick you, because they will definitely try to throw that in there. Here's another example. They might ask you to order these. This was the ordering part. What if you are given 2.4, 2.04, and 2.21? And it said to order from, let's say, least to greatest, I suppose. Least to greatest, smallest to biggest. Least to greatest. So if you look at these, which one of these is the smallest and why? Now what might help you in this is, see how these both have 2 digits after the decimal? You can always add zeros, like I said, and make that 2 digits after the decimal. So maybe that'll help you see which one. What is the smallest one there? Madison Siller?
2.04.
Right, 'cause that's like $2.04. Followed by, next smallest would be, or the next biggest, I guess. Lauren?
2.2.
Yeah, $2.21 or 2.21, and then the biggest one is that 2.4. Again, noting that even though this one had fewer digits in it, it was bigger because of the place of that 4. This had a 4 in the tens place, this had a 0 in the tens place, that had a 2 in the tens place. So decimals can be a little tricky, but they're really not that terribly difficult. I think we shall stop with that. It's exciting.